All right, this is lesson 6, order of operations for chapter 3, powers and exponents. You may have noticed that we skipped a video for lesson 5. And so lesson 5 is actually going to be an individual assignment that we complete in class. So if you're working ahead and you've already worked on lesson 5 by yourself, that's great. Hopefully from lesson 5 you have noticed that a power with an exponent of 0 is actually equal to a value of 1. And that's something that you kind of need to remember and be able to demonstrate. And so for today, we're going to be using that principle. We're also going to be using the exponent laws, all 5 of them, and some problem-solving strategies to try and evaluate expressions that involve exponents. We are also going to start including coefficients. So you need to know what a coefficient is before we begin. So you have a box in your notes that says a coefficient is. I would like you to please fill in that box so that way you know what a coefficient is before we begin. Okay, so we're going to write these out as repeated multiplication again. And so we have 3 times 2 to the power of 4. So because the 2 is in brackets, 2 is the base that is repeated 4 times. So we have 3 times 2 times 2 times 2 times 2, or 2 4 times. And when we multiply this out, we get 48. In your calculator as well, you could have gotten 3 times 2 to the power of 4 using your little up arrow, and you would have got the same value. When we look at b, we have -3, and again, it's right beside our bracket. That tells us that it is being multiplied to the -5. Our base is the -5, so that is the part that will be squared 2 times. So we have -3 times -5 times -5. Negative base is being multiplied in even amount. This is going to give us a positive 25. So we have -3 times positive 25, or -75. In the last example, we have -4 to the power of 2. Now, I hope you notice that there is no brackets, so the negative is not part of the base. So we have -4 times 4, or we have negative times 16, so -16. Okay, so in each of these examples, we have shown a coefficient. The 3, the -3, and the negative sign are actually all coefficients. So I hope that you came up with an understanding that a coefficient is a number that multiplies each term in an expression. So in the previous examples, there were only 1 term inside each set of exponents. On the last example, there wasn't actually a number that we saw as the coefficient. We just had this negative sign, and we said that this is the coefficient. This is actually like having a coefficient of -1. We'll see some more examples of this as we go forward. Okay, so you have a table. I would like you to try filling in this table of what is the expression, what is the coefficient, what is the power, what does it look like as repeated multiplication. And we're going to check this over in class tomorrow to see kind of how you do. But we'll do these next examples together. Okay, so we have 2 times 4 to the power of 5. So we have a coefficient of 2, a base of 4, an exponent of 5. So 2 times 4 times 4 times 4 times 4 times 4. So this is the same as 2 times 1,024, or 2,048. Please note that this is not similar to our examples where we had 2 times 4 to the power of 5. Okay, 8 to the power of 5 has a much different value than 2 times 4 to the power of 5. 8 to the power of 5 gives us 32,768. So a much different value. So making sure that we're following our order of operations, and if you're not doing repeated multiplication, like we showed here, if you're just typing it in your calculator, you're making sure that you solve the exponent first before you multiply by 2. Looking at B, again we have a negative coefficient. We have a negative 5 as our base. So this is like negative 3 times negative 5 to the power of 3. Following order of operations, I'm going to solve my exponent first. So negative 3 times negative 125. I know that it's negative because the base is negative and we have an odd exponent. Negative 3 times a negative 125 gives us a positive 375. And again, positive 15 to the power of 3. So if I multiply first, positive 15 to the power of 3 does not have the same value. Okay, going on to our next examples. Again, we have some order of operations that we need to think about. And so we have some subtraction, we have some multiplication, and we have an exponent in this first example. So I'm going to follow BEDMAS, and I'm going to solve my exponent first. So 8 minus 4 times carries down because we haven't used it yet. 3 to the power of 2 gives me 9. Now I have a subtraction and a multiplication. Following BEDMAS, we're going to multiply first. So the 8 and the subtract carries down. 9 times 4, or 4 times 9, we get 36. Lastly, we're going to subtract. We have 8. So you have 8 and you owe me 36. You are going to be left owing me a lot of money, and you still owe me 28. Keeping in mind our adding and subtracting integers. Looking at B, we have 5 squared divided by negative 3 squared plus 5.2. So we're going to solve the exponents first, and I'm going to evaluate both exponents because they're not going to have any implications on our order of operations or anything else if I do them both at the same time. So we get 25 divided by positive 9 plus 5.2. And these numbers don't divide nicely, but this question hasn't told us that we need to leave things in fraction form or anything like that. So we're actually going to divide, and we'll keep 2 decimal places. So we're going to divide before we add, and we get 2.77777 repeating. The end of your calculator, you probably will see an 8. It's rounded up. So we're just going to keep 2.78, just 2 decimal places, and then we're going to add 5.2. So now we can add, and we get 7.98, and we know that this is a rounded value. Okay, so we had to round. Looking at C, we have 5 to the power of 3 minus 2 times 3 to the power of 3. So again, we have exponents, we have multiplying, and we have subtracting. We're going to solve the exponents first, and I can do them both in the same row. If I want to do them at separate steps, I can do that too. 125 minus 2 times 27. I almost wrote 9 there. 3 to the 3 is 27. 3 to the 2 is 9. Now we have subtraction and multiplication, so we are going to multiply before we subtract. So 125, subtract carries down, subtract 54. Now we can subtract, and we get 71. Our last example, we have 46 minus 3 squared plus, in brackets, 7 cubed minus 4 squared. Okay, so again, I'm going to evaluate all of the exponents first, so I'm going to figure out what these are. Now notice we don't have the same base being subtracted inside the brackets, so we can't use our exponent rule to combine those exponents. Okay, so we get 46 minus 9 plus bracket 343 take away 16. And you shouldn't have needed a calculator for any of those exponents. They are on your perfect square and perfect square cheat sheet table. I would much prefer you using that or using your mental math to figure those out as opposed to your calculator at this stage. Next thing we have to do is we have a set of brackets. But if you notice, the only operations that are going on are adding and subtracting. So if we solve the brackets first, or if we work from left to right, it's not actually going to impact our solution. However, out of force of habit, we can keep solving using left to right, using our brackets first. So 343, take away 16, we get 327. And so 46, take away 9, plus 327, and we get 354. Oh, sorry, 364. I typed in 36, not 46. There we go. Okay, last example for this video is a bit of a problem solving, but more of a visual question. So it says write an expression, so we want an expression that has powers to determine the difference. So difference telling us to find the subtraction between the volume of a small cube and the volume of a large cube. Okay, so hopefully we notice that they are cubes, which means they have equal base, length, and height. I know this diagram doesn't show that very well, but they've told us that it's cubed, so we're going to ignore the poor drawings and understand that cubes have equal side lengths. And so then it says the volume of a cube. Well, volume of any shape is length times width times height, or base times width times height, or however you want to think about it. What we're doing is we'll multiply the three dimensions together. However, because they're cubes, it's actually like saying length times length times length, or length to the power of 3. And again, that could be base to the power of 3 or height to the power of 3. Doesn't matter. One of the side lengths to the power of 3. So in our large cube, we have a volume of 8 to the power of 3. And in the small cube, we have a volume of 6 to the power of 3. And then we would have to make sure we have our centimeters in there, right? And our centimeters would also be cubed. And so we want an expression with powers that shows the difference between them. So 8 centimeters cubed, take away 6 centimeters, all cubed. Okay, so this is our expression, so that's the first thing done. And then it says what actually is the difference, and so we're going to evaluate this. So 8 to the power of 3 is 512 centimeters cubed. Take away 6 to the power of 3, which is 216 centimeters cubed. Again, I've just been using our perfect cube table on our cheat sheet. And when we subtract these, we find the difference. So 296 centimeters cubed. So we could say the volume of the large cube is 296 centimeters greater than the small cube, or the small cube is 296 centimeters cubed smaller than the large cube. So basically that's how much less it could hold. If we were talking milliliters, it would be 296 milliliters less or 296 milliliters more for volume. All right, that is it for this lesson.